So let's take a look at what classes look like in Python. Fortunately, while they do introduce a little bit of new syntax, it's not too much. You start off by defining a class along with its name. We follow the standard Python style guidelines of giving our class names capital letters, starting with a capital letter. So we'll give it a customer with a capital C, and we give it a set of parentheses. For now, there's nothing in the parentheses. Later on, you'll see what goes in the parentheses. And then we define our methods, which again are the functions we just talked about. And so maybe we'll have something like that add account method, right, where we might give it an account to be defined. Now you'll notice something special happened. When I started typing this in, PyCharm automatically inserted an extra parameter at the beginning called self. Self is the representation of the instance of the class. Because when you're writing your code methods, you need to be able to access the data for the particular instance your code is running on. Right? Before we wrote our functions, and they were just standalone functions, they didn't have any connection to anything else. If you wanted to access data, you passed it in as parameters. Now our code in a class, our methods, are operating on an instance. And so self represents that instance. In practice, self is just a variable which points to this special data structure which is sort of hidden that represents the class. And we're going to use this new notation with dots to access the members or the data members of the class, the instance variables. And so when we add an account, maybe we will have, maybe each instance of the class has a list in a variable called accounts. But we don't just say accounts, we say self.accounts. And what this means is we're accessing the accounts variable, instance variable, within this particular instance. So this is going to be a list, and we will append onto it account. All right. So this kind of thing would work, but we are missing one crucial and required part of class definitions, and that is an initialization method. When you make a new instance of a class, you are required to call some special code which initializes that instance, and that's called a constructor. The constructor in Python for each class looks like any other method, but it has a special and somewhat unusual name. It's basically init, I-N-I-T for initialize, but with an initial 2 underscores, and then following 2 underscores, and then self. Okay, so in fact you'll notice that there were a bunch of other possibilities that popped up that got PyCharm showed with other double underscores. Leading and trailing double underscore in method names is Python's way of indicating that these are special names that are used by the Python system, Python language. So we can make a constructor, this initialization method, and this is where we define our instance variables. And we do this by just defining a variable and giving it an initial value. In this case, though, instead of just saying accounts equals list, we say self.accounts equals list, because we're saying this is a variable that is going to be used in every instance. Every time you create an instance of a customer, you're going to get a new accounts list. All right, I also want to name the customer name. So we could just give it an empty string, but I want every single customer to have a name. I want that to be a requirement. So rather than creating a customer with an empty name and then adding another method for setting its name, I'd rather have the initialization method, have the constructor include the opportunity for setting the name right there. And the reason is that's going to reduce the opportunity for a bug. If we had it separated, then it would be possible for someone to create a customer and forget to set their name, and now you'd have a customer with no name, and that would be bad. So instead what we can do is put in the constructor after self a variable, a parameter, and then that parameter is a variable which is local to this method, and we can use that to assign it to this particular instance. And then you'll see in just a second how we can set this. I think this is actually enough, so let's go ahead and use this class. So we'll go down here and write some code that makes a new customer. So maybe customer 1 is a new customer, and the way you make an instance of a class in Python is just to type in the name of the class followed by parentheses, and if there are any required parameters, you type in those, enter those as arguments. Now notice we don't have to enter self. Even though self is defined in all class methods as a first parameter, when you are passing in arguments to methods in classes, you never pass in self. Those are implicit. When you're calling a constructor, well, it gets created for you. And then when you call some of these other methods, it gets also created for you in a different way. So let's go ahead and make an account. For now, we haven't really said what an account is, so we'll just call it a string. So now what we want to do is call the account add account method for this particular customer, and this is where we use the next special new bit of class syntax, which is we take the particular instance we care about, C1, and then we put the dot, and then we can call methods on that instance. So we can say c1.addAccount and give it an account name, maybe checking. So what this is going to do is call add account for this particular customer. Just to make this clear, let's go add another account. Maybe we'll call this one savings. And now to go show this really is completely generic, let's go do the same thing and make an account for Dana and give her customers, make her customer C2, and she will only have a savings account. And so now we've got two customers, each with their own accounts. Now that we've got all this nice code, I want to see what's going on. So let's see how we can do this. Unfortunately, we can't do the simple thing, which is to just print C1. It would be nice if we could just print these customers. Well, actually, we will be able to, but right now they're not going to do anything too interesting. If we do this, what it's going to say is C1 is customer instance at this blah. That's actually an address in computer memory of where that particular instance is located. And C2 is this one. Okay, so that's not very helpful. What we want to do is get at this content. Well, one way to do this is with a debugger, right? We can set a breakpoint here, run the debugger, right? This other code has run, and we can now go over here in the debugger and see here's C1. It says the same mess, but there's a little arrow here. We can open up C1 and look at this. Its name is Ben, and its counts is a list of checking and savings. And C2 is the name of Dana, an account of savings. All right, that gives me pretty high confidence that we've actually got these data structures set up right. But it would sure be nice if we could print it out and see what was going on a little bit better. So we can do that by adding a print method to customer. Now, we could do this kind of a simple way by, say, defining a print method. But print is a reserved word in Python, so we would have to call it something like print me. Okay, well that will work, and we could do stuff like print self.name and print self.accounts. And instead of saying print C1, we would have to say C1.printMe. And this is actually an okay way to do this. Right? And C2.printMe. If we do this and run it, we will get the right results. Ben has checking and savings, and Dana has savings. Nice. Turns out we can do a little bit better. Instead of doing it this way, we can actually define a special method in the class that is called a description string, which is underscore underscore str underscore underscore. Right? Again, I told you we're going to see a lot of these things. This is basically a special method that says how a customer should be printed if it's asked to be printed by Python. And instead of printing, what we want to do is return a string with this nice information. So we're going to have to return a string. We'll build up a string. We'll start it by setting it to empty string, set result, add onto it, concatenate onto it self.name, and then add on further the count list. If we do this, it'll all be on one line. So maybe what I want to do is add on after name a new line, so it'll go to the next line, and we can do that with a special character in quotes, which is \n. And now we don't have print me anymore. We can now go back to what we had before, print C1 and print C2. And when you print an instance of a class, it checks to see what the str method does. And instead of just printing instance, if there is one, it'll print whatever string you generate. Of course, you have to return that string as well. And now when we print this, we get an error because, again, you cannot concatenate string and list objects, so we need to convert this list into a string. Try again, and now we get something very nice just with a simple print statement. Okay, we have got our first class with constructor, methods, and print statements. We're making progress.